Good morning, guys. How's it going? So, moving along in our 30-1 course, the next topic we're doing is we call logarithms. So this is chapter 8 in the textbook, and the first topic is called understanding logarithms. So, goal for today's lesson, guys, is when you're sitting around the dinner table tonight and your parents ask you what you learned in school today, and you tell them logarithms, and if they ask you what a logarithm is, you'd say that the purpose of a logarithm is to isolate for an exponent in an exponential equation. Okay, so we'll explain this more in some examples in a second here. But if we have log base c of x equals y, okay, so what you see over here, so if I compare this expression to this expression, I can say that these are actually the same expression. One's expressed in logarithmic form and one's expressed in exponential form. So in exponential form, we have c to the y equals x. Okay. Now, what we're doing here is like we want to have a way is like how can we get this y by itself? Okay. So if we need to isolate for this y over here, and the answer to that is using logarithms. So another way of writing this form over here is the logarithm in base c of x equals y. So I'm going to say, to write out how we should read this. All right, so again, log base c of x equals y means that this base here is the same as this base here in the exponential equation. So those guys match up over here. This part over here, which we call the argument or the answer, like that, in an exponential equation over here, goes in this part of the logarithm equation, and the exponent gets isolated over here. Okay, so a logarithm is a way that we can do this, and when I say that we can do this, this is a way that a computer or a calculator can quickly isolate for an exponent when we need to figure out what an exponent is in an equation like this. So if I have log base 2 of 36, what I'm going to do over here, I'm going to say that this is, let's say that this is equal to y. Okay, so when we say evaluate each logarithm, so what this means is, this means our base is 2, and we're just going to convert it into exponential form. Our base is 2, y is our exponent, and our answer, or our argument, we call this, is 36. Okay, so now I have to think, okay, well, what does, sorry guys, there's a quick typo over here. Let's just make this a 32 instead of a 36. I meant to make this a 32. Okay, so now we need to think, well, what exponent satisfies this equation? Well, the answer is it's 2 to the 5th, right? So 2 to the 5th equals 32. Therefore, y equals 5. Okay. Similar idea for log base 4 of 64. We're going to make this equal to y here. And now we think, well, this is 4 to the power of y equals 64. Okay. So therefore, think, well, 4 to what exponent equals 64? And that answer is y equals 3. Okay, so that's how we get the answer 64. So therefore, our answer to this question is 3. Okay, so in this case, we have a log of 10,000, and we have no written base over here. Okay, so we call this the common logarithm. Okay, so the common logarithm, so if we do not write a base right here, we're going to assume that the base is going to be 10, okay? Now, there's something later on that you'll learn, not in this course, but you'll learn it in calculus when you take that, something called the natural logarithm. Is something kind of different. Well, same exact idea, except the base is going to be a different number other than 10. But for a common logarithm, okay, so log of 10,000 means the same thing as having a base of 10. So we're doing the same thing for this guy here, and this means 10 to the power of y equals 10,000. Okay, so what exponent satisfies this? It's 10 to the power of 5. Okay, so this answer is going to equal 5. Log base 2 of 16. Okay, so 2 to the what power equals 16. So guys, if you struggle with this as well, we talked about in our last unit, well, we can kind of, so how do we solve exponential equations? 16 can be written as 2 to the power of 4, like this. So therefore, y equals 4. Okay, so this is how we can do this as well. Now, guys, there's a way in class that you can do these on your calculators as well, and I will definitely show you how to do those ones in class, but I'll wait to show you on the calculator screen to do that as well. All right, E, log base 3 of 1 over 81. So this means 3 to the y equals 1 over 81. And what we have to remember about reciprocals like this, well, we know that 81 is 3 to the 4th, so 1 over 81 would be 3 to the negative 4. So therefore, our y value here is negative 4. Log base 4 of 8. So solving this exponential equation, okay, well, I can't make 8 a power of 4, but I can make 4 a power of 2, and 8 is a power of 2 as well. So this is the same thing as 2 to the 2y equals 2 cubed. So therefore, 2y equals 3, and y equals 3 over 2. Okay, so this is how we kind of evaluate logarithms as well. And again, guys, your calculator can do all of these as well, but you need to have a kind of a sense on how we kind of convert between logarithmic and exponential form. Okay, log base 9 of 243. Similar idea, 9 and 243 are both base 3. So this is 3 to the 2y. 243 is 3 to the 5th. And we have y equals 5 over 2. Similarly, so we have log base 8 of 1 over 32. We have 8 to the y equals 1 over 32. Same thing, we're going to convert these all into base 2. 8 is 2 cubed. 1 over 32 is 2 to the negative 5. And we get an answer of y equals negative 5/3 for this guy. Okay, example 2, solve each logarithmic equation. So a logarithmic equation, guys, is an equation like this, where we just have to isolate for our variable. Okay, first one, pretty straightforward over here, but okay, so I'm not going to say pretty straightforward. The basic strategy, I'm going to say for most of these questions, is we need to convert these questions into exponential form and then solve for a variable. So in this case, we know that this is the base, this is the exponent, and the x is the argument. I'm going to put in brackets the answer. So in this case, our base is 3, our exponent is 5, equals x. So we're looking for x in this case. So 3 to the 5th is 243. 243 equals x. Okay. In this case over here, we have log base c of 5 equals 3. So again, c is our base, 3 is our exponent, 5 is our argument. That means we have c cubed equals 5. And then what I'm going to do next is I'm going to take the cube root of both sides of the equation. So in this case, c would be the cube root of 5. Okay, so just talking about this screen a bit, guys. I'm gonna say these are very, very basic logarithmic equations. The last topic we do in this unit is solving logarithmic equations. So they get more complicated than this, but this is just definitely kind of an intro into this topic over here as well. Example 3, convert from exponential into logarithmic form. Okay, so again, we have the base, we have the exponent, and we have the argument or the answer. So when we convert, if we have c to the y equals x, this goes into log base c of x equals y. So again, this is the base, the exponent, and the arguments here. Okay, so back to this example. This would be log base 2 of 32 equals 5. Okay, so the point is, guys, this expression here and 2 to the 5th equals 32 are representing the same thing. Okay, now again, what's different? A logarithm isolates for the exponent, and so there's some questions where we have an equation and we need to isolate for the exponent. This is what does that for us. In this case, it's going to be log base 3 of 1 over 243 equals negative 5. Last one means is log base 16 of 8 equals 3/4. Example 4, same thing, just going the other way around. First one means, so here's our base, our exponent, our argument, 4 to the power of 3 equals 64. Okay. All right, so this is another one we call a common logarithm. So for a common logarithm, guys, we need to remember that the base is 10. So I'm just going to write in a little 10 here. We just assume this is base is 10 if we don't write it, so we just need to know that. So this means 10 to the power of 6 equals 1 million, just like that. Okay. In our last topic, guys, we talked about graphs of exponential functions. Okay, so here's a graph of f of x equals 3 to the x. Our domain and range, domains from negative infinity to positive infinity goes forever to the left, forever to the right. Our domain, it starts at 0, but not including 0, going upwards. Okay, so it's from 0 to infinity. Part over here, again, x equals f of y is the inverse. And if you remember, guys, from inverse, so what we do is if we have a point x, y on our original, it becomes y comma x. So all we're doing is we're flipping our x and our y values. So at this point, negative 2, 0.11 is going to become 0.11, negative 2. That's going to be this point here. 0, 1 becomes 1, 0. Sorry, guys, I missed a point here. Negative 1, 0.33 is 0.33, negative 1 will be here. 1, 3 becomes 3, 1. 2, 9 becomes 9, 2. Okay. Now, other things, if we remembered that this guy had a horizontal asymptote at y equals 0, that means our inverse graph is going to have a vertical asymptote at x equals 0. This graph is going to look like this. Sorry guys, it should be a smoother curve than that, but it's kind of looking like this idea over here. Part C says determine the equation for y equals f inverse of x. Okay, so again, what this notation means is the inverse function resolved for y. Okay, so what we mean by that is if our original was y equals 3 to the x, there's our original function. That means our inverse function is I'm flipping my x and my y. So I'm going to put in brackets, this is the inverse. Now, how do we solve for y? Now, y is an exponent. The reason why we do logarithms is to be able to isolate for an exponent in an exponential equation. So in this case, if we want to resolve for y, that means we get log base 3 of x equals y. So this is the inverse resolved for y. So same thing as y equals f inverse of x. Okay, so that's what this is over here. So the point we're trying to get is if we have the function y equals 3 to the x, the inverse function is going to be y equals log base 3 of x. Okay, and so that's what we're kind of doing for this guy over here. Okay, our next topic, topic 8.2, guys, is called transformations of log functions over here. So purpose of today is kind of introduce you to what, well, teach you what logarithms are. This is what a base logarithmic function looks like, and we're going to discuss this in more detail in the next section as well. Okay, example 6, there's some more, I'm going to say, complex type of logarithm things over here. Now, one, guys, we could solve all three of these on our calculator, but I think it's kind of important to kind of understand why these work the way they do, and we're going to kind of go over that. So if we have 6 to the log base 6 of 12, what I'm going to do first, I'm going to say, well, let's say let log base 6 of 12 equals x. I'm just looking at the exponent over here. Then, so what's this mean in exponential form? It means 6 to the x equals 12. Okay, so here's kind of a weird step. We're going to be substituting a function almost into itself over here. If I have 6 to the x equals 12, and log base 6 of 12 equals x, I'm going to make this replacement here. Log base 6 of 12, which is equal to x, is going to go in for x here. And what the result is, 6 to the log base 6 of 12 equals 12. Okay, so you'll see questions like this kind of pop up. Okay, this is a very, I'm going to say, complex way of understanding how, another way of writing the number 12, 6 to the log base 6 of 12. So almost what happens, like this base of 6 and this base of 6 almost like cancel each other out, and the result is this 12 over here. This answer over here, see how this 9 matches up with this 9 over here. This answer is going to be 15. Doing it the long way. So we do this. And then make this substitution in here. So we get the answer of 15 over here. guys, we don't need to show this all the time, but these questions do pop up on exams like that, so you need to kind of be aware of how this rule works. Okay, we have log base 4 of log base 2 of 256. Okay, so for 256, we're going to deal with just this part over here. So log base 2 of 256, I'll say that equals to x. That means 2 to the x equals 256. And guys, play around with the calculator a bit, but you're going to find that 2 to the power of 8 equals 256. So therefore, log base 2 of 256 is equal to 8. Okay, so this 8 can replace this expression over here. And we're left with log base 4 of 8. So if I make this equal to x, that means 4 to the x equals 8. Okay, now I can't convert these guys, so the 8 is not base 4, but they're both base 2. So this is 2 to the 2x equals 2 cubed. And we get an answer of 3 over 2. Okay, so you'll see questions similar to this as well, guys, like that, and this is how these guys work out. All right, guys. So guys, I hope that you kind of understand what logarithms are right now. Guys, just encouraging you guys to keep up with your practice on this stuff. You know, it definitely takes practice until you guys get good at this stuff. And please just send me a message if you guys have any questions, and I will see you guys in the next video.